Hello again. Okay, so I found the rental introduction gets written out here. Part 2, surface shaders. Introduction, surface shader, physically basic lighting model. Surface shaders, physically based. Surface shaders. Surface shaders is most easy to use with Unity standard lighting models. Lambert. Okay, surface shader output. Surface shader output has this type of the outputs: albedo, base color, texture, normal map, emission, specular, gloss, alpha. This is the old Unity lighting models, Lambert and Billing foam. And here you can sampling textures, albedo, surface output, saturate albedo. Okay, here is a standard lighting model. This is only available in Unity 5 or higher or newer versions. In standard lighting model we have simple Lambert. This is a lighting model, surface output, PBR, physically based. As you can see in PBR shaders we have albedo, normal, smoothness, occlusion, metallic, output. Okay, so we want to start right my first shader, remove this values and use my own shaders, my variable intensity. So first we need to create a color RGBA variable float for RGBA, my text output. The name is not important. You can use any name if you like. The type we want to convert my texture, diffuse texture. We want to apply diffuse texture with input UV. We want to apply UV to main texture. Okay, now you can we can use line texture.rgba. This is RGB. This is the shader output. This is the shader output. We only applies the albedo with my main diffuse texture. Okay, now you can test your first shader, create assign your material. Now we need my shader diffuse, ground. Okay. We have only a diffuse texture applied into albedo. The lighting model is PBR, standard lighting model, and and we just applied the diffuse texture. Now we want to multiply the diffuse texture into my first color. So open here. This is my first color name, my color, my first color. Here you can multiply to main texture, albedo texture, or use here. Both are same. You can use this or this. Both are same. The result should be same. Will be same. As you can see, we multiply the color into albedo texture. So we can add the color. As you can see, the result is different. Add the color. Okay, this is the correct way to apply color into your texture. I want to show you that the shader is same thing as your Photoshop or image editing works. For example, in image we have RGB. In here we have RGB. We can create a new layer with red color and multiply the color into the texture. As you can see, the result is same because we use the same logic in Photoshop. For example, you want to use only red channel, you can use your R, or you can apply the color here. We only use R channel. Here you can see we use it R channel. You can use green channel of texture. Green channel. Or RGBA channel. RGB channel. Okay. Second one is use metallic value or smoothness. We just need to here we want to change it to the smoothness. Range between 0 and 1. The default value is half of the 1. Another is metallic. Okay, reassign again here. Float, smoothness, float, metallic. Now you can use this values here. It's metallic, smoothness. Now you can assign smoothness here. Here we have a shader. Select the shader and watch your metallic conflict with previous values. Previously we have some variables here. Remove. Okay. Now you have two options for reflections and metallic. You can create a metallic color variable. The name is not important. Metallic color. As a color, the default value the black color. You assign here fixed for RGBA as a color. Now here you can multiply the metallic into metallic color. Metallic color, metallic value. Okay. This is not affected to nothing. You can use standard specular setup. Standard specular. Now we can use specular instead of metallic. Specular lighting model. Okay, here we have now a specular lighting model. Using specular lighting model, you can assign the specular color. Okay. We have two PBL lighting models, standard and specular. Standard lighting, standard specular. Smoothness, and here you can assign alpha. Alpha should, you can change render type to transparent to get access to alpha value. You can create a transparent render type transparent alpha fade. Here you can assign my color off. Now we can use alpha from here. Now we have transparented shader. Transparented shader. Okay, we don't need currently alpha channel. Okay, you can create, for example, multiply PNG, save your shader into TGA or PSD to get access to alpha channel. Get access to alpha channel, grass. This is TGA, what is the color? Oh, color. Let's remove this and store in TGA format. TGA format or PSD format. Both have support the alpha channel. Okay, now we want to use alpha channel and multiply it to specularity. Here is undefined. Alpha value should be 1. Now we want to multiply the alpha channel of the diffuse texture into a specular color. Specular color to color into diffuse texture alpha channel. As you can see, we have multiply into alpha channel. Specular, if you remove it, or you can multiply into smoothness. Okay, here you can see very beautiful smoothness value. Multiplied into alpha channel. Okay. You can see more examples from building shaders, from Unity surface shaders here, normal mapped shader, has normal mapped shader, normal diffuse, normal diffuse, normal diffuse, normal diffuse, bumped shaders. You can see the bump map UV. We must create my normal map here, flow to UV, my normal map. Here is UV of your textures, and unpack your normals. Output normal equal unpack my normal map, normal map, my normal map, my normal map UV, my normal map UV, my normal map. Now you have options to apply normal map. Can see your normal map. Here you can change UV. Here you can change outlet UV. If you like to use main texture UV in your normal UV, it's possible. You can use styling to your normal map. What happens? What happens? What happens? What happens? What happens? Normal unpack. Okay. You can find more example of surface shaders here. Illumination. Illumination has emissive. You can see emissive here. Emission. Or you can see here the legacy self. Legacy illumination. This is the source of the legacy illumination. Okay, this video was about shader programming basics. Now you know what is the shader, what is the lighting model. Unity uses the standard lighting model, standard specular or PBR, and some legacy lighting models, Lambert, Billingfong. For example, glossy lighting model is Billingfong, diffuse Lambert. Both are legacy in Unity 4. Unity 5 has a standard PBR or standard specular PBR lighting model, standard lighting model. Physically based standard lighting model enable shadows and light types. Okay, now you know what is the surface shader main function to return the pixel color. Albedo, normal, specular, all are returns the pixel color. Surface shader is same as a pixel or fragment shader. Body function, body function. Input use it to get access to UV or view angle to simulate or calculate reflection probes or cube maps. You can find more details in the net Okay, here is output for shader and output types for standard lighting model. For lambda we just have albedo, normal and alpha plus emissive. For PBR we have specular, smoothness, metallic. For standard metallic, and for glossy billing fong we have gloss, emissive and specular. Okay, this is your shader body. Here is and fallback. If your shader does not support in your target device, the shader automatically switch to this shader. If your target device doesn't support this shader, should be fall back to this shader. It's good to use always legacy diffuse as a fallback, because diffuse is supports on most platforms, even to low-end devices. Okay, I forget to tell you some more options on public classes. We have ability to use the header, my description. No, here, no, here. PBR settings, my descriptions. As you can see, descriptions added here. The same thing is on scripting. For example, header, my color, same thing. For scripts. Okay, now you know what is the shaders. Shaders should be applied into materials to define how to render the surface. Using shaders you will define how to render surface and use materials for all for your model, and shader to define how to render the surface. Okay, now we want to learn how to use Amplify Shader Editor to create easily your surface shaders without touching any code. You can easily switch to lighting models without touching the code. Write your shader name, change shader model, cooling mode, front, back face cooling, front cooling. You must define your cooling here. Here, cool off. Here you can cool off, cool front. Amplify shader will help you to select easily everything. Default should be back, render type forward, deferred, cast shadows. The Amplify Shader Editor will help you to get a fast access to shader programming, automatically generate for you. This is the save button, save your shader. Here for my test, my first Amplify shader. Now you can see your shader generated automatically. My first shader, open in code, create a shader for you with your selected setting. This is the Amplify node settings. Don't remove this here. If you remove these lines, you cannot open again Amplify Shader Editor. Okay, I will show you how to use Amplify Shader Editor in the next videos. I hope you have enjoyed this videos. I hope.